Hello, this is section 6.1, solving systems of two linear equations using substitution or eliminations. Objective tips for this one is number one, solving linear system of the two equation with the two variable by graphing, and solving linear system of the two equation with two variable by substitution, and solving linear system of the two equation with the two variables by elimination, and then solving application using the system of the equation. So the word problem that you met before usually comes with the using the system of the two linear equations. So two variable means you always get the x and y. Okay, so linear systems and the graphing. So the first five sections in this chapter will be almost entirely devoted to one type of problem, solving linear system of the equation, which means when you have a system of the equation, you can solve for actually the five different ways to solve. So first one is using graphing, substitution, elimination, and also you can use a matrix, and then you can use the determinant, which is the using Cramer rules. So there will be five ways to solving the same problem. So we will start this section by using graphing to solve the system of the two linear equation is in two variables. So when they say solve the system, which means by graphing, which means we are looking for the intersection of the two lines. Okay, so the place of the intersection, which is come out as an order pair, that will be the solution. So what if the two lines doesn't intersect, which means there's no solution? What if two lines are exactly the same, which means every single point on the line intersecting each other, so we call that as an infinitely many solution. Alright, so example one, use graphing to solve this the linear system. So I want to label first, since we have a two equation, so I want to graphing one at a time. So equation one, I have a y equal to 3x minus 1. So this linear equation, I'm using the slope, which is a 3 over 1, which is up 3, down, right 1. And then y intercept as a 0 and negative 1. So once you have a 1 point from the line and the slope, you can graph the line. So starting from the 0, negative 1, and then you go 1, 2, 3 up and right 1. 1, 2, 3 up and right 1. Okay? And that's the point. So you got it. So let me actually connecting it, make a straight line. So that's the line of the equation 1. The equation 2, which is 2x plus y equal to 4. Yeah, you can just use the slope and y-intercept too. So subtract 2x both sides, which is y equal to 2x plus 4. So this time slope is negative 2, which is negative 2 over 1, which is down 2 and right 1. And y-intercept is 0, 4. So from the 0, 4 right here, let me use the red pen, okay? And then you go down to 1, 2, and right 1. Up, down to 1, right 1. Then you have another, the line of 2. So as you notice, there's an intersection, right? So which is this is going to be the 1 and 2. So this is the solutions. Okay. All right, let's go to example 2. Use a graphing to solve the linear system. So 2x plus 3y equal to 0, which is number 1. And then the number 2 for the second equation. So yeah, I like the equation 1. 2x plus 3y equal to 0. Subtract 2x both sides. 3y equal to negative 2x divided by 3. Y equal to negative 2 third x. So slope is, I want to put the negative on the top with the 2, but you can put the negative on the bottom of 3 too. So which means down 2 and right 3. And then y-intercept for this one is 0, 0. So from the 0, 0, you go down 2 and the right 3. 1, 2, 3. Down 2, right 3. Also, you can go to, instead of this one, you can put that as 2 over negative 3. You also get the directions of up 2 and left 3. So from here, 0, 0, up 2, left 3. And then up 2 and left 3. So if you connect those all points you have, it makes a line. If it doesn't make a line, we are in trouble because this is a linear system, okay? All right, now equation 2. Now we have 5x minus 6y equal to negative 3. So for y, subtract 5x both sides. And then negative 6y equal to negative 5x minus 3. Divide by negative 6. Cancel. Y equal to 2 negative become positive. X. And then plus 1/2. So slope is 5 over 6, which is up 5, right 3. But y-intercept is 0.5, which is, I don't think I like it. So what I do is I try to actually get the nice of the point and then use a slope to get the line. So if I'm thinking about it, about this case, what's the best points I can use? Since I have 5x minus 6y equal to negative 3, so I need to, if I use the, let me see as the y equal to, let me put the LCD as a 6x, okay, so 5 over 6x, and then if I multiply 3 both sides as 1/2, I got 3 over 6. So this is actually the 5x plus 3 over 6. So if I make a 5x plus 3 as a multiples of 6, and then, yeah, we'll get the nice ones. So let's see what's the best x's I can use here. So if I said that's equal to 6 or 12, what about 12? Oh yeah, what about 12? 12 nice. Oh no. Okay, on this time, 12 doesn't nice. Okay, what about 18? Oh yeah, 18 is not bad. So if you subtract the negative 3 both sides, I got x equal to 5x equal to 15, and divide by, oh, x equal to 5. So I think I want to use a 5. So if I use a 5, so 5 times a 5 plus 3 over 6, and hold a second. Oh, it's a 3. So what am I doing? 3, right? So 3. So x equal to 3. And then I got 18 over 6. So I got 3. Which means when x is 3, so this time instead of the y-intercept, I'm using the 3 and 3. So 3 and 3 is also the solution for that, the equation 2. So 3 and 3 is right here. 1, 2, 3, 1, 2, right here. And then I go to the 5 to up and the right 6, but I don't have much space in here. So I need to put down this one as a negative to put it on. Okay, that's the same thing as the 5 over 6, right? So instead of the going to, so instead of you going down, and then you going to the left, okay? So from the 3, 3, I need to go 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and 6 right here. So okay, so which is, yeah, this is actually the line. The problem is, I know they're intersecting in here, so this time it's hard to read. I know this is the solutions, but as a graphing, it's hard to read because it's somehow it is as a place of the fractions. So I'm just gonna say solution. So why we start this chapter considering the graphing as the first method for the solving linear system? Based on the following discussion about the graph of the two line, every system of the linear equation will have one of the 3 different outcomes. So one of the 3 different outcomes means it could be the one solution, it could be a no solution, it could be a infinitely many solution. And then that's all. You always get the one of those, okay? So consider following the three linear system this time. So equation 1 and 2. So equation 1, y equal to 2x minus 4. So slope is a 2, which is a 1 up and right, from the y-intercept of 0 and negative 4. So from 0 and negative 4, 1, 2, 3, 4 right here, you go 1, 2 up and right 1, 1, 2 up and right 1, okay? So this is a line, which is equation 1. And then equation 2, you have y equal to 2x plus 1 this time. So slope is a 2, 2 over 1, up to right 1, y-intercept from the 0, 1. So from the 0, 1, you got 1, 2 up and right 1, 1, 2 up and right 1, okay? But as you notice, two lines looks like a parallel, right? Which means when they have a same slope, and then they never meet. So this is actually the case of no solution. Okay. All right, next page, please. Okay, I have a y equal to 2x. So equation 1 and equation 2. So equation 1, y equal to 2x. So slope is a 2, which is over 1, go up to right 1 with a y-intercept of 0, 0. So from the 0, 0, you got 1, 2, and right 1. 1, 2, and right 1. Okay. So this is a line. Now, equation 2, you got x plus y equal to negative 3. So for y, subtract x both sides, y equal to negative x minus 3. Slope is negative 1 over 1, which is down 1, right 1. Y-intercept is 0 and negative 3. So from the 0, negative 3, right here, go down 1 and right 1. Down 1 and right 1. Also same as up 1, left 1. See, this is a line. Okay, so this is a intersection. So intersection is negative 1 and negative 2. So this is a one solution case. One solution case. All right, the third problem, number 1 and number 2. Y equal to negative 1/3 x plus 1. Slope is negative 1 over 3. Y-intercept is 0 and 1. So down 1, right 3 from the 0, 1. 1, 2, 3, and, 1 down and the right 3. Sorry about that. 1 down and right 3. Which is a 1 up and left 3. And then you'll see the line. They're just connected. Alright, the next one, equation 2. You got x plus 3y equal to 3. So for y, so subtract x both sides. 3y equal to negative x plus 3 divided by 3. Y equal to negative 1/3 x plus 1. And then as you notice, this equation 2 is exactly same as equation 1. These are the same, right? So when you are graphing, you get exactly the same line. So which means these two lines meet every single point. So it's gonna be the infinitely many solutions. But this time we cannot say that the solution is all real numbers, right? Because still this point is not a solution, okay? The point that I have here, okay? Only the solution is from the number on the line, okay? All right, let's look at the next page. So in general, the following describes the three possibilities for the solution to every linear system with the two equations and two unknowns, as well as to introduce the mathematical technology used for each situation. So A, if you have a two parallel line which has the same slope and different y-intercept, we have always no solution, which is inconsistent because of the no solution. Excuse me. Two lines with a different slope, which means there is always a solution, single answer, one solution with a come with the order pair. The two copies of the same line, which is the lines exactly the same, which is the same slope and the same y-intercept, that means you have to say infinitely many solution, which is, we call this the dependent, which means other cases are independent. So independent means two lines, the different line, But dependent means two lines exactly the same line. And then if there's a solution, we call the consistent. If there's no solution, we call the inconsistent. In means not consistent. Now, I'm going to introduce a substitution method. That's another way you can solve the system of the linear equation. But also, if it's not a linear equation, we can actually use for the non-linear system of the equation too. Graphing shows the three possible outcomes for the linear system, but lack the accuracy in determining solution. We will now, because of the second problem, I showed that I can't really tell you what is the solution. But in this case, I can tell you what it is because I know that the solution come out as a fraction or decimal. Now, we will consider the substitution as another method that will allow us to determine the exact answer to every linear system. So if you use a substitution, you're always going to find the answer if there's an answer available. So we can describe the process of this substitution as follows. So number one, pick an equation and then we have to solve for a single variable, which is we plug it in other side of the variable to another equation. Substitute the expression for the isolated variable instead one into the other equation. Solve the resulting equation and back substitute to find the other value that we are still missing. So number three, solve the following linear system by substitution. So there's two equations. Equation 1 and equation 2, but this time I choose the equation 1 because x has a 1 times x, which is, I think I can solve for x, which means I'm not going to see any of the fraction in the equation. So pull out the equation 1, x minus 4y equal to 13, and then I'm going to solve for x, which means I'm going to add 4y both sides, x equal to 4y plus 13 or 13 plus 4y, doesn't matter, okay? Now I'm going to call this equation is 1 as a prime because later on when I'm looking for the x value, I think I want to call it as a 1 prime equation, not the 1. Because the labeling is kind of name of the equation, okay? So now I'm going to substitute 4y plus 13 into another equation, which is right here. So now I have 3 times of x, which is now I have a 4y plus 13 plus 2y equal to negative 3. So I just substitute for 4y plus 13 for x. Now I'm going to solve for y. So when you distribute the 3, I got 12y plus 39 plus 2y equal to negative 3. And then I got 14y plus 39 equal to negative 3. Subtract 39 both sides. 14y equal to negative 42 divided by 14. I believe this is a negative 3. Now, in order to find the x, I'm going to substitute the y equal to negative 3 into the equation 1 prime. So x equal to 4 times negative 3 plus 13, negative 12 plus 13, which is a 1. So x is a 1, y is a negative 3. So order pair is going to be 1 and negative 3. Order pair is always x and y order pair, okay? All right, see. Example 4. Solving the following linear system by substitution. So this time, okay, no matter what you choose, we're going to have a fractions, okay? So we have to deal with it because we have to use the substitutions. So I think I want to use the equation 1 again because that number looks smaller, okay? It doesn't really matter, okay? So 4x minus 3y equal to 2. And then this time, do you want me to solve for y? Okay, I can do that. So I want to solve for y. You don't have to. You can solve for x. X is a positive, but I want to show you another way. So subtract 5x both sides. I got negative 5x plus 2. And divide by negative 3. Cancel. I got 5/3 x minus 2/3. So I'm going to call this the equation 1 prime. Now I'm going to substitute this one into the equation 2 next to the 2. So I got 7x minus 2 times of 5/3 of x minus 2/3 equal to negative 6. And then I'm solving for x. So I'm going to distribute the negative 2 inside. I got 7x minus 10, because 2 is the same as 2 over 1, okay, not 2 over 2. So 10 over 3x positive 4/3, which equal to negative 6. Now, if you don't like the 3 on the bottom, I can multiply 3 both sides to cancel the 3. And then if I distribute it, I got 21x. If I distribute it, that 3 cancel, I got negative 10x. If I multiply, 3 cancel, I got 4. It's equal to negative 18. Now I have 11x plus 4 equal to negative 18. Subtract for both sides. I got 11x equal to negative 22. And divide by 11x equal to negative 2. Now I'm going to substitute the negative 2 into the here. Now so for y, 5/3 of negative 2 minus 2/3. I got 2 over 1 as negative 10/3 minus 2/3, which is negative 12/3, which is a negative 4. So your solution come out as negative 2 and negative 4. So when you're graphing this, I don't think that's not that bad, okay? The third one is elimination. Okay, elimination is one of my favorite actually. The third method we'll discuss in this section, which is elimination. So to introduce the process of the elimination method means actually we can call that as addition method. So why we call the addition method same as the elimination method? Because we are adding the system. So when you're adding it up vertically, you'll see 2x, but y is a cancel equal to 6. So x is 3 already. So you find the solution for x. Now, in order to find the y, you just need to substitute one of the equation. So I'm going to use the x equal to 3 in the substitute in the equation 1. So equation 1 is this, but I know that x is a 3. And then so for y, which is a y is a 2. So you already have a solution of 3 and 2. So very simple, okay, good to use. So the most important takeaway from this example is that the addition of the two equations resulted in elimination of the variable because the coefficient of this variable in these two equations were opposites. So using the information, we can describe the process of elimination as a method. Number 1, multiply one or both equation by constant, which is some number that you need to make that is opposite. That one variable have the coefficient, the other opposite. So opposite means if you have a 2, negative 2 is the opposite. If you have a negative 3, and 3 is the opposite, okay? So that's the things that we want to multiply to get it out and then cancels out when you add it. Add the two equations, solve the resulting equation, and back substitute, find the value of the second variable, just like a substitution method, okay? So we have the same thing as an equation from the previously. So we are using the elimination this time. But x is a variable 1 and 3 and negative 4 and 2. So none of the equation has actually the opposite, okay? Opposite means same number, a different sign, okay? But in order to find the opposite, I think the y variable already have a sign of the opposite. And then if I multiply equation 2 by 2, I think I can easily get the 4y. So I'm going to multiply equation 2 by 2 first, okay? So 2 times of 3x plus 2y and negative 3 times of 2. So distribute the 2, I got 6y plus, 6x. What am I talking about? 6x plus 4y equal to negative 6. So this is equation from number 2. So I'm going to go number 2 prime. So I have keep the equation 1. And equation 2 prime is now this. And then now, so this is a 1 and 2 prime, okay? Now I'm going to add it up. So I got 7x. And cancel y. And then I have a 7. So divide by 7, x is a 1. Now, in order to find the y, you can use any of the equation you want. But I think I'm going to use the equation 2 this time. So if I use the equation 2, which is a 3x plus 2y equal to negative 3. So x is 3 times 1. And then 3 plus 2y. Subtract 3 both sides. 2y is a negative 6. Divided by 2, y is a negative 3. So solution is 1 and negative 3. Alright, another one. Elimination method, okay? So this time, actually, I don't think you just need to multiply one of the equation to get the opposite, okay? Because there's no actually the LCM, okay? So either way you can choose. So, but I think the 2 and 3 is small number than the 5 and 7. So I want to make the LCM for 3 and 2, which is a 6. So I'm going to make the both number to 6 by multiplying. So in order to get a 6 from 3, I need to multiply by 2. In order to get a 6 from the 2, I need to multiply by 3. So equation 1, I'm going to multiply by 2. So 2 times 5x 3y equal to 2 times 2, which is 10x minus 6y equal to 4. So I call this a 1 prime. And then equation 2, I'm going to multiply by 3 by 7x minus 2y equal to negative 6 times 3. And then 21x minus 6y equal to negative 18. And then I need to make I need to make the opposite numbers. So I need to multiply by negative 1. And then I got negative 21x plus 6y equal to 18. So I'm going to put that number on here. So negative 21x plus 6y equal to 18, which is a 2 prime. Add them up. So I got negative 11x, cancel 22, divided by negative 1 is a negative 2. And then in order to find the y value, you can use any equation you want. So let me use equation 1 this time. So I got 5x minus 3y equal to 2. X is negative 2 now. Negative 10 minus 3y equal to 2. Add 10 both sides. Negative 3y equal to 12. Y equal to negative 4. If we divide by negative 3 both sides. So solutions are negative 2 and negative 4. Alright, next page. Inconsistent and dependent systems. At the start of this section, graphing was investigated as a method to solve the linear system of the two equations in two variables. Although the method lacked accuracy, the graph of two lines shows that the three possibilities for the number of the solution to linear system are none, one, or infinitely many solution case. However, every example in this section has a result in a single solution. We will now discuss a linear system that has no solution or infinitely many solutions, systems that are called the inconsistent for the no solution, and then dependent case for the infinitely many solutions. Let's solve the following linear system. So this time, I think I want to use elimination because you can make 3 to 6 by multiply by negative 2 as the opposite, right? So if we multiply negative 2 of 3x plus 5y equal to negative 2 times negative 2, I have a negative 6x minus 10y equal to positive 4, which is the equation 1 prime. And then I put the equation 2 under, which is 3, add it up, and then cancel 0 equal to 7. Oh, so there's no x and y left, right? So this is actually not true. So this is a case of the no solution because 0 never equal to 7. The next one, I think I want to use a substitution. But this equation already won for the substitute form. So I'm going to plug it in right here. So equation 2, I have a 2x minus 3 times of 2 thirds x plus 1 equal to negative 3. So 2x, and then if I distribute the 3, cancel 2x minus 3 equal to negative 3. So 2x cancel negative 3 equal to negative 3, which is true, right? Because of true, and then in this case of the infinitely many solutions. Okay? Alright. Next page. This true statement allows us to determine that the given system has infinitely many solutions, called a dependent system. We can describe the solution set as follows. So you can say x is a t, and then if you use t for x, and then we'll get to the y comes out as this form. So which means whatever x you given, so if let's say t is a 0, y is a 1 because t becomes 0, right? And then let's say t is a 3, I think it's a 3 because the 3 times cancel 3 plus 2 plus 1 is a 3, right? So yeah, there are so many pair of the solutions. Application of the linear system. In this final discussion of this section, we'll use the system of the two linear equations to solve the application problem that involve two unknown quantities. Alright, example 7. A nurse needs to prepare the medicine dosage of 10% for the patient. She only has access to the medication strength of 6% and 12%. So she can find the 10% as a bottle. So how much of the 6% and the 12 medicine should be mixed to prepare to 24 milliliters of the dosage of the 10%? So we're going to change the percentage as a decimal. So 0 0.06, 0 0.12, and 0 0.10. And then she needed it, the 24 of the 10% from the unknown of the 6% and then the unknown as a 12, but I don't think it's going to be same. So get a dosage of the 6% medicine means it's going to be 0 0.06x, and then because you multiply, get this dosage, okay? So 0.12y, and then 0.10 times 24. So we're getting a two-system equation from this column to this column. So if I put it in, x plus y equal to 24 as a first equation, and 0 0.06x plus 0.12y equal to 0 0.10 times 24 as a second equation. And then equation 2, I'm going to multiply 100 both sides to get rid of all the decimal place. So if I multiply 100 times up, 0 0.06x plus 0 0.12y equal to the multiple by 100 to the 10 is actually the 2 as 10 times 24. So if I multiply here, move the decimal 2 place by 6x, move the 2 place right, you got 12y, and then 240, which is, I'm going to call this equation 2 prime. And then equation 1, I'm going to multiply by negative 6 in order to get the opposite, right? So negative 6 times of x plus y of 24 times negative 6. So negative 6x minus 6y equal to negative 144, isn't it? 24, 12, yeah, 144. So I'm going to call this the 1 prime. So I put the negative 6x minus 6y equal to negative 144, which is a 1 prime. And then I'm adding up together. So cancel 6y equal to 6, and then 96. And then divide by 6 both sides. So y goes, I think 16, isn't it? Right, so 6 goes 9, 1 times, which is 3 times, yeah, 16. So y is a 16. So since y is a 16, plug it into the equation 1. So x plus 16 equal to 24. X equal to subtract 16 both sides, which is, I think it's 8. Yeah, so we got those, right? So which means x was represent the 6% medicine, okay? So 6% medicine is going to be the 8 milliliter. And then the 12% medicine need a 16 milliliter. So that's how you mixed it. And then you can earn the 10% medicine. All right, next page. A single engine plane leave an airport and travel to the 600 miles in 6 hours into a headwind. With a tailwind on the return, the plane completes the flight in 4 hours. So headwind means wind is kind of blocking the speed of the airplane, which is make it slower. And then the tailwinds means the wind actually push the airplane go faster. That's why it takes a different hours, okay? So flight with a headwind take 6 hours, and then the flight with a tailwind is 4 hours. And then so the airplane speed is 600, but the headwind actually subtracting the speed of the wind, okay? So I want to say let x is be the speed of wind. So 6 minus x and this 600 minus x and plus x because tailwind getting faster. So in order to get a distance, you gotta multiply and they get the distance, okay? So you got 6 times of 600 minus x, and then 4 times of 600 plus x. Oh, okay, but hold on, sorry about that. Yeah, we already had that kind of stuff. So in this time, good thing is there's a distance. So they have the same distance actually, 600. Okay, because it's actually the return trip. So you get the times 6 times of 600 minus x, a distance equal to 600 to go, and then 4 times of 600 plus x equal to 600 to go to. And then you can distribute the 6 if you want, but I want to actually cancel some of the number, okay? So so equation 1, I have a 6 times 600 minus x equal to 600. Of course, you can distribute the 6 to get 3600 minus 6x equal to 600. But I think I want to starting with a divide by 6 both sides. So cancel, you got 600 minus x equal to 100. So 1 prime. And equation 2, 4 times 600 plus x equal to 600. And then I'm going to divide by 4. Then I got 600x plus x equal to 4 goes 6 1 times. I think it's 150. So I'm going to put the 600 and plus x equal to 150. What am I doing here? Okay, I'm sorry. Let me try this one. Yeah, I don't think this is not what I'm talking about. Sorry about that. I was thinking about one variable. Alright, so this one I want to redo it, okay? Sorry about that. So I want to say rate is x and y, which is different. Take a 6 hours and 4 hours, and then distance are the 600. Okay, so single engine airplane, right? Yeah, I think that's what it is. And then the x is actually the 600. Oh, I'm so sorry. We don't have actually the speed of the airplane either, right? Okay. What am I thinking? Okay, so on this time, yeah, I just forgot one thing, okay? So let x the speed of plane and y be the speed of wind. Sorry about that. So this is actually the x plus y, and this is x minus y. That's actually the better. I don't know why would I put that 600. So that's not the, yeah, this is a miles, which means the distance, okay? So sorry about that. You got 6 times x plus y equal to 6. That's a lot better. And then you got 4 times x minus y equal to 600. So I'll do the same thing. So I'm going to multiply by 6. I'm going to multiply by 4. So if you do that, I got 6 cancel, x plus y equal to 100, which is a 1 prime. Divide by 4, x minus y equal to 150, which is equation 2 prime. Now adding it up. Cancel, 2x equal to 250, and divide by 2, x is a 125, which is miles per hour. So wind speed is actually together is a, divided by 2. Okay, hold on a second. What's happening here? So Edwin, I have to do another way. Another mistake. Very clumsy. Sorry about that. It's gonna be negative and positive. Make it slower and faster. That's a big mistake. Sorry. So it's gonna be negative and positive, which is negative and positive. Okay. So you're actually you're getting yeah, so 125. Sounds good. All right, and then in order to get a y, so x plus y equal to 150. So x is a 125 plus y equal to 150. Subtract 125 both sides. Y equal to 25. Which means the speed of plane is 125 miles per hour. And then speed of wind is 25 miles per hour. Sorry about that. All right. Thank you for listening.